Now we're going to look back over all the stuff we've looked at for systems of equations. So beginning with solving these systems. Looking at your equations, you can determine how many solutions you have. And for linear, we're either going to have one solution, one intersection, or no intersection and no solution, or the lines are the same and they're infinitely many solutions, or all real numbers. All right, so if they're parallel, there's no solution. If they're the same line, it's all real numbers, and every other system is only going to have one solution. So we talked about solving by substitution. So first you solve one of the equations for one of the variables. Generally you pick the one that has a coefficient of 1 or -1 because that's going to eliminate having any fractions. Then you substitute that equation into your other equation, replacing the variable you solved for. That way we only have one variable in our equation and we're able to completely solve for that variable. Then you solve for the variable, then you plug it back in to find your other variable, and then you can check your solution. Then we looked at elimination. So elimination, one, you want to make sure both equations are in standard form, or at least you want your x's and y's to be on the same side. So you don't want any fractions, but it's okay if your a value is negative as far as elimination goes. Then you're going to multiply the equations by numbers. That's going to allow one of your variables to cancel when you add them. So you need one positive, one negative. Then line up your equations vertically and add your like terms. One variable should cancel during this step. If it doesn't, you've done something wrong. Then solve the remaining equation because you're down to one variable and plug it back in to find the other variable and check your solution. And the third way is graphing. So one, you want to make sure that your equations are in slope-intercept form just because we want a bunch of points. So you want exact points. Then you graph both of your equations, and wherever they intersect is your solution. So first we're going to do this set by substitution. So I've already got y by itself, so I'm just going to take what I know y is and plug it into y of my second equation. So I have 2x minus, and then in parentheses, x plus 6, because I'm subtracting this whole thing, not just x. And that equals 4. So I'm going to have to distribute that negative. So 2x minus x minus 6 equals 4. 2x minus x is x. And then to get x by itself, we just add 6. So then we get x equals 10. Now I'm not done here. There's only half of my answer, so I'm going to plug it back into one of my equations. I'm going to plug it into the y equals because I want to know what y equals. So I have y equals 10 plus 6, so we get y equals 16. So then my answer is 10, 16. I'm going to do the same example but with elimination. So I need to make sure that my x's and y's are on the same side. So for this bottom equation, I'm going to subtract that x over. So I'm going to bring the top equation over because it's already set up for me. Then I'm going to rewrite this one with my x first. So I have a negative x, a positive y, and then that equals 6. Just looking at my equations right now, I know that my y's cancel. Sometimes you have to multiply, and if I wanted to cancel my x's, I could multiply the bottom equation by 2 and cancel the x's. But my y's already cancel, so we're just going to go ahead and cross those out. And then 2x plus negative x is just 1x. 4 plus 6 is 10. So I got x equals 10. Now I have to plug that back into one of my equations. So you can pick either one. So if I pick the first one, we have 2 times 10 minus y equals 4. 20 minus y equals 4. Subtract the 20. So negative y equals negative 16, and then divide by that negative 1. So y equals positive 16. So again, I get my answer as 10, 16. And the third way is graphing. So to do graphing, I need to make sure both of my equations are in y equal. So this bottom one's already ready to go. The top one, I'm going to subtract the 2x from both sides. So we get negative y equals negative 2x plus 4. And then divide everything by that negative 1. So we get y equals positive 2x minus 4. Alright, just because I know my answer gets kind of big, I'm going to make my x and y axis kind of off to the side here. Oh, that was a hot mess. Okay, there's my x and y axis. So to graph the first one, I'm going to go down to negative 4, which is off my page here. And then I'm going to go up to right 1. So it's going to put me here. Up to right 1. And remember, for your first equation, fill in your entire grid. That way it's easy to see as soon as your second equation crosses. Alright. Ooh, missed that one. So there's my first line. Then my second line, we've got x plus 6. I'm going to go up to 6. And then I'm going to go up 1, right 1. I'm going to keep going until I cross my line, other line. And as soon as I cross it and find that intersection, I don't need any more points. I'm just going to graph. And then this is my answer, which if we count, will get us again 10, 16. So those are solving systems of equations. And we also looked at systems of inequalities. So I'm going to take these same equations, but I'm going to graph them as inequalities. Alright, so again, I know that most of my graph is going to be, it's kind of high where they intersect, so we're just going to draw an x and y axis kind of low. Okay, so the first one's in standard form, so we can graph it in standard form. So if I cover up my x, I get that my y-intercept is negative 4. And if I cover up my y, I get that my x-intercept is 2. So I have negative 4 and positive 2. And this one's going to be a dotted line because it is just less than, not or equal to. And it's a terrible dotted line. Alright, and then deciding where to shade, I can plug in 0, 0. 0, 0 is not on my line, so I can plug it in and see if it works. So this whole side becomes 0. And 0 is less than 4, so that means I'm going to shade where 0, 0 is, which is the top half. Then for the second equation, it's a slope-intercept form, so I'm going to go up to 6. Right there. And then my slope is up 1 over 1, so I get a couple points. This one's a solid line because it's or equal to. And then for this one, I want all the y's that are bigger, so I'm also shading above. So then that means that my solution to the system of inequalities is everything up here, because that's where it's blue and red. So your system is an infinite number of points for any system of inequalities, and that's where your two shaded regions overlap.